Hi listeners, you are welcome to the continuation of our online tutorial class from your favorite student ScoreBooster, your online tutorial provider on WAEC, JAMB, NECO and NAPTIP exams. For today's presentation, we shall be considering the concept of Charle's law. I am Bangbade A. Now, before we proceed, we need to consider the learning outcomes of this presentation, which goes thus. At the end of these presentations, listeners should be able to state Charle's law. Listeners should be able to state also the mathematical expression of Charle's law. They should also be able to explain the graphical representation of Charle's law. And lastly, they should be able to solve relevant UTME questions relating to Charle's law. Now on to Charle's law. Charle's law states that for a fixed mass of gas at constant pressure, the volume phi is directly proportional to the absolute temperature. I repeat, Charle's law states that for a fixed mass of gas at constant pressure, the volume phi of the gas is directly proportional to the absolute temperature. Absolute temperature is the temperature in Kelvin. Mathematically, phi, the volume phi, is proportional to temperature T. So, phi is directly proportional to T. If we introduce the constant of proportionality, then it will give us phi equals kT, where K is constant of proportionality in this case. Now, we can proceed to make K the subject of formula by dividing through by T, and that will give us K equals phi over T. Now, if we have more than one volume and one temperature, then we are going to have K1 and K2. Our K1, constant 1, will be volume 1 over temperature 1, while our K2 will be volume 2 over temperature 2. That is K2 equals phi2 over T2. Now, if K1 equals K2, then our phi1 over T1 will be equal to phi2 over T2. The next we shall be considering is the graphical representation of Charle's law. The plot of volume phi versus T is a linear graph for a fixed mass of gas at constant pressure. So, for Charle's law to hold, the pressure must be constant, and the volume is directly proportional to the absolute temperature. Now, we have two plots here. The first one is talking about the volume against temperature in degrees Celsius. And as you can see, you have a straight line graph passing through an intercept on phi axis and meeting the T axis at minus 273 Kelvin, which is equivalent to minus 273 degrees Celsius, which is equivalent to 0 Kelvin. And this particular temperature is called absolute temperature or absolute zero of temperature. Absolute zero of temperature or 0 Kelvin. It is the temperature at which the volume of gas is reduced to 0. The intercept of the gas on T-axis is minus 273. That means the value of temperature is minus 273 degrees Celsius, while volume is 0. This temperature at which the volume is reduced to 0 is called absolute zero of temperature or 0 Kelvin. The second plot we are having at the right hand side here is talking about the volume against Kelvin, temperature in Kelvin, and of course there is a straight line graph. Now on to sample questions. The first question we shall be considering comes from 1986, number 24, and the question goes thus. A gas occupies a volume of 300 cm cube at a temperature of 27 degrees Celsius. What is its volume at 54 degrees Celsius when the pressure is constant? You have option A to be 150 cm cube, option B is 273 cm cube, option C is 327 cm cube, while option D is 600 cm cube. Now on to solution. The first step is to write out the given parameters, and from the question we're given the initial temperature T1 to be 27 degrees Celsius, which can be converted into Kelvin by adding 273 Kelvin. So at 27 degrees Celsius will be equal to 27 plus 273 Kelvin, and that is equivalent to 300 Kelvin. We're also given the initial volume V1, which is 300 cm cube. Then we're given the final temperature T2, which is 54 degrees Celsius. As usual, we are going to add 273 Kelvin to convert it to Kelvin, and therefore 54 degrees Celsius will be equal to 54 plus 273 Kelvin, which is equal to 327 Kelvin. Now our V2 is unknown in this case. Of course, that is what they asked us to find. So using the formula of Charle's law, we state that V1 over T1 equals V2 over T2. Then when we substitute, our V1 is 300 cm cube over T1, which is 300 Kelvin, equals V2 over T2, which is 327 Kelvin. So if you cross multiply, we're going to have 300 cm cube times 327 Kelvin equals 300 Kelvin plus times V2. We can make V2 the subject by dividing both sides by 300 Kelvin, and that will give us 300 cm cube times 327 Kelvin divided by 300 Kelvin equals V2, making our V2 to be 327 cm cube, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 1998, number 19, and the question goes thus: a gas has a volume of 100 cm cube at 27 degrees Celsius. If it is heated to temperature T until the final volume of 120 cm cube is obtained, calculate T. Option A is 33 degrees Celsius, option B is 60 degrees Celsius, option C is 87 degrees Celsius, while option D is 144 degrees Celsius. Now on to solution. The first step is to write out the given parameters, and from the question we are given the initial volume V1 to be 100 degrees Celsius. Then we are also given the initial temperature T1. We are given from the question the initial volume V1 to be 100 cm cube. Then we are given the initial temperature T1 to be 27 degrees Celsius. So, and now is equivalent to 27 plus 273 Kelvin, which will give us 300 Kelvin. So our initial temperature will therefore be 300 Kelvin. Then we are also given the final volume to be 120 cm cube, while the final temperature is not given. Now using the equation of Charle's law, we state that V1 over T1 equals V2 over T2. If we substitute, that will be V1, which is 100 cm cube, over T1, which is 300 Kelvin, will be equal to V2, which is 120 cm cube, over T2, which is unknown. So we can cross multiply to get 100 cm cube times T2 will be equal to 120 cm cube times 300. Then we can make T2 the subject by dividing through by 100, and that will give us T2 equals 120 cm cube times 300 Kelvin over 100 cm cube, and that will give us 120 times 3. Of course, you know, 100 will give 100 in 300 will give us 3. So we arrive at 120 times 3, which is 360 Kelvin. So back to convert 360 Kelvin to degrees Celsius, we subtract 273 from it, and therefore that will give us 360 Kelvin minus 273 Kelvin, which will give us 87 degrees Celsius, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 1989, number 14, and the question goes thus: the volume of 10.0 cm cube long is trapped in a tube at 27 degrees Celsius. What is the length of the volume at 100 degrees Celsius? You have A to be 124.8, option A to be 12.4 cm cube, option A is 12.4 centimeter, then option B is 13.7 cm, option C is 18.5 centimeter, while option D is 37.0 centimeter. Now on to solution. So from the question we are given the initial length, which is 10 centimeter, then we are given the initial temperature to be 27 degrees Celsius. To convert degrees Celsius to Kelvin, we add 273. Therefore, our T1 here will be 27 plus 273 Kelvin, which will be 300 Kelvin. Then our L2 here is not given, while our T2 is 100 degrees Celsius. Then to Kelvin will be 100 Kelvin plus 273 Kelvin. That will give us 373 Kelvin. So using the equation of Charle's law, V1 over T1 equals V2 over T2. When we substitute, in this case, since our volume is not given directly, the volume is equal to area times length, and hence since the same liquid is used, so the area 1 will be the same thing as area 2. So in place of volume 1 now, which is our V1, we can write area times the length given, the length 1, which is 10 centimeter, then over our temperature 1, which is 300 Kelvin, will be equal to volume 2, which will also be area times length 2, our L2, over the temperature, which is 373 Kelvin. Then we can cross multiply. If we cross multiply, we get 8 times 10 times 373 Kelvin will be equal to 8 times 300 Kelvin times L2. Then we can make L2 the subject by dividing both sides by 8 times 300 Kelvin. And that will give us L2 equals 8 times 10 times 373 Kelvin over 8 times 300 Kelvin. So A will cut A, then 10 times 373 divided by 300 will give us 12.43 cm cube, making option A the correct answer for this particular question. Now on to your practice question. The first question here for your practice comes from 2008, number 21, and the question goes thus: a sealed flask contains 600 cm cube of air at 27 degrees Celsius and is heated at 35 degrees Celsius at constant pressure. The new volume is dash. So you have option A here to be 508 cm cube, option B is 516 cm cube, option C is 608 cm cube, while option D is 616 cm cube. Now the expected answer here is option D, which is 616 cm cube. The next question for your practice comes from UTME 1979, number 17, and the question goes thus: if a given mass of gas at constant pressure obey the relation volume is proportional to the absolute temperature, the gas is said to obey dash: A. Hooke's law, B. Boyle's law, C. Dalton's law, D. Charle's law, D. Newton's law. You know, if you can recollect, we said the volume is directly proportional to the absolute temperature at constant pressure. That condition is Charle's law. If the volume of a gas is directly proportional to absolute temperature at constant pressure, then that is condition of Charle's law. Therefore, the correct answer here will be option D. Now, the last question here for your practice goes thus: if the volume of a fixed mass of gas was 100 cm3 at 20 degrees Celsius, what will be its volume if the temperature is doubled, provided the pressure is constant? You have option A here to be 50 cm3, option B is 100 cm3, option C is 200 cm3, while option D is 400 cm3. Now, hint here is that phi is directly proportional to t, meaning that as phi increases, t also increases. As phi decreases, t also decreases. So expected answer here is 200 cm3, making option C the correct answer for the question. Now, our next video will be on Prayer's law with sample questions and solutions from UTM. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects relating to UTME. Thank you.